All right, this is section 4.3. We're still talking about logs, and we're going to go over some rules that we have with logs, okay? So we have the product rule, quotient rule, and power rule. We have these with just normal non-logs, I guess you could say, as well, okay? Where we have adding exponents, subtracting exponents, multiplying our exponents. Okay, and we're basically just going to do that same thing here. Okay, if you are multiplying inside your parentheses with your log, you're going to add the logs. If you're dividing, you're going to subtract the logs. And if you have something, I know this might be a little difficult to see, you should be able to see it better on your paper. Log base b of m to the p power equals p times the log base b of m, okay? So we're just taking this exponent out front, okay? That's the power rule. That one's really the only one that's a little different than the other two. The other two really go along with our product rule and quotient rule when we are multiplying and dividing exponents, okay? So we can expand logarithms, okay? Obviously, we're going to do that by our rules. So if you look here, here, and here, those are more condensed than these. Okay, these are expanded more. So we're going to use our rules and do that, all right? So here we have log base a of x to the fourth power. Okay, so this would be the power rule because we need to take this 4 and move it out front, okay? So we would get 4 times the log base a of x. And that's it, okay? That's expanding that logarithm. Here, we are dividing in our parentheses, so we are going to subtract our logarithms, okay? So you're going to have log base a of the numerator, 76, minus log base a of the denominator, 13, okay? Your bases are the same, okay? And then you'll have numerator minus denominator, okay? This one looks vastly different than the other ones that we just did, okay? So we have a radical, all right? We obviously have rewritten those every single time. So we're going to write log base c, okay? And if we want to write this radical as exponential, okay, our root that we are taking becomes our denominator, okay? So we would have y to the 3/2 power times z to the 2/2 over x to the 4/2, okay? Well, we can simplify that down a little bit, okay? Log base c of y to the 3/2 times z, okay? 2/2 is 1, and z to the first is just z. And then 4/2 just gives us 2. Okay, and we're done with that part. So now in our parentheses, we have a couple of things going on. Our y and our z are being multiplied together, and then it's divided by our x, okay? So this is multiplied, so we're going to add these two and then subtract our x squared, okay? So we would write this as log base c of y to the 3/2 power plus log base c of z minus log base c of x squared, okay? Now we have powers. So we've used the product rule and the quotient rule, but then we have a power here and a power here, okay? So those need to move to the front of their logs, okay? So you have 3/2 times the log base c of y plus log base c of z, okay, nothing you could do with that one, minus 2 times log base c of x, okay? So I took my powers and moved them to the front, okay? And I had that, and that was all, okay? So that one used all three of my rules, okay? But just take it step by step, turn them into exponents, okay? Simplify those, and then look inside your parentheses and say what's going on, okay? Well, these two are multiplied together, so I'm going to add. And then I'm dividing by this, so I'm going to subtract. And then if you have exponents, move them out front. Okay, what about this one? We're dividing, so we're going to subtract. So log base 5 of 125 minus log base 5 of y. Okay, well, look at log base 5 of 125. Okay, if we did our circle, we would have 5 raised to the what power equals 125. And you would tell me 3. 5 raised to the third equals 125. Okay, so log base 5 of 125 equals 3. So this is actually 3 minus log base 5 y. Okay, so I just knew what this was, so I calculated it. Okay, so all of that is expanding logs. If we can expand it, we can condense it. Sorry. So we're just going to do the opposite, basically. All right, so we have this guy right here. Okay, we're subtracting, so we know we're going to divide somewhere in here. We have some numbers out front. Okay, those need to go back to our powers, right? These need to go back to our powers. So we get log base a of x to the 5th minus log base a of y to the 3rd. Okay, now we're subtracting, so we're going to have log base a, and because we're subtracting, we're going to put it back in division. Okay, we're using the quotient rule, we're just using it backwards. Okay, so we have numerator and denominator. And we're done. Okay, condensing it into a single log. All right, well, here we have some addition, we have some subtraction. Okay, so these two are going to be multiplied. This tells you to divide. These need to go back as powers. Okay, so once you've identified all that, you just have to take the steps to do it. Okay, start with your powers, move those back. Okay, so you'll have log base b of x to the 3rd plus log base b of y to the 5th minus log base b of z to the 2nd. Okay, then you have plus and then minus. So that means that you're going to have log base b, and then you have x to the 3rd times y to the 5th. Then you're subtracting, so you're going to divide by z to the 2nd. And you're done. Okay. So not too bad. Okay, and you have this thing called change of base property, and that says for any logarithm bases a and b, okay, and this also may be a little difficult for you to see. For any logarithm bases a and b, and any positive number m, log base b of m can be made into log base a of m over log base a of b. Okay, so your base becomes what you're taking the log of over here. So this is saying that the logarithm of m with base b is equal to the logarithm of m with any new base divided by the logarithm of b with that new base. Okay, that was a lot of words. Let me show you what I mean. Okay, so use common logs to evaluate. We have log base 3 of 81. Okay, we can split this into log of 81 over log of 3. Okay, here's my base was 3, and I took the log of it at the bottom. Okay, if you type that into your calculator, you would get 4. Okay, we can do the same thing here. Okay, so we have log base 5 equals of 125. Sorry, let me say it again. Log base 5 of 125 equals something. Okay, we've done this by hand, and we would go 5 raised to what power equals 125, and you would say 3. Or you could do log base 5 of 125 equals log of 125 over log of 5. And you should get 3 when you do that. So this one is by hand, okay, using your circle. This one is by calculator, right? And the key is making this base. You're going to take the log of 125 over the log of whatever your base was, which was 5, okay? So for this one, you would write log of 2,506 over log 7, and you get some decimal for 0.0220. Okay, so just another way for you to use common logs to evaluate those. Sometimes it works by hand, like log base 3 of 81, you could have also done by hand and said 3 to what power equals 81, and you would get 4, or you could write it using common logs.